Hello students. Now we are going to discuss about pH and application of pH in daily life. First come to the pH. Actually pH is scale for measuring hydrogen ion concentration in solution is called pH. How much ions are present in a solution? This is expressed by one scale that is called pH. In pH, P stands for potence. This is a German word and its meaning is power, or we can say potential, power of hydrogen or potential of hydrogen. On the pH scale, we can measure pH from 0 to 14. 0 means very acidic, 14 means very alkaline or very basic. Higher the hydronium or hydrogen ion concentration, lower is the pH value. Remember it. More the concentration of hydrogen ion, its pH will be lower. Actually, the formula of pH or definition of pH is this. pH is the negative logarithm of hydrogen ion concentration. This represents the hydrogen ion concentration. If any formula is placed in a square bracket, then this represents the concentration of that formula. Mathematically, we can write pH is equal to minus log of hydrogen ion concentration. Actually, detail of this formula and calculation or numerical based on this formula is out of scope of class 10th. For neutral solution, pH is 7. If acidic solutions are there, pH is less than 7. Basic solution, pH is more than 7. As the pH value increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution. That is increase in strength of alkali. Here, you can say every solution have H plus ion and OH minus ion at the same time. But if concentration of H plus ion is more compared to the OH minus ion, this is acidic in nature. If both ions are present in the same concentration, that is neutral solution, and if concentration of OH minus ion exceed, then it is alkaline in nature. Is that clear? Now see, with the help of this diagram you can say easily this is for neutral solution, pH is 7. If we go from this side, this to this side, acidic nature increasing because concentration of hydrogen ion is increasing. Clear? As the concentration of hydrogen ion increasing, pH is decreases. This side pH is decreases, and this side basic nature is increasing. It means concentration of hydrogen ion is decreasing and concentration of OH minus ion is decreasing, and pH will also increase. More the concentration of hydrogen ion, less the pH. Is it clear? Now pH is determined by pH paper or universal indicator or pH meter. Actually, this is the one strip of pH paper. What are the colors can be obtained? When pH paper is dipped in a solution, then depending on the nature, color is produced, and this color is compared with the standard colored chart. Actually, this is the one standard colored chart. You can say in the middle, that is, this is green is there, this is pure water, this is pure water. If we go from this to this side, pH is increasing, and at this is blue or violet blue color, and this is sodium hydroxide solution, about pH is 14. If we go from this to this side, pH is decreases, and if red is there, it means it represent the acidic solutions. Red or orange or yellow, this represent the acidic solution. The strength of acid and base depends on the number of H plus ions and OH minus ion produced respectively. Acids that give rise to more H plus ions are said to be strong acids, and acids that gives less H plus ion are said to be weak acid. In the same way, we can say if any base gives more OH minus ion, strong base, less OH minus ion, weak base. Some examples of strong acid are hydrochloric acid, sulfuric acid, nitric acid. Examples of weak acids, acetic acid, carbonic acid, H2CO3. Strong bases, sodium hydroxide, potassium hydroxide. Weak bases, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. These are the some example of strong acids and bases, weak acids and bases. Importance of pH in everyday life. Our body works within pH range of 7.0 to 7.8. Actually, pH of our blood is slightly alkaline. If this pH is disturbed, we face some problem in our body. Acid rain makes the survival of aquatic life difficult. What is this acid rain? When pH of rainwater is less than 5.6, it is called acid rain. And as we know, this rainwater of this acid rain ultimately go to the ponds or rivers, and it make that water acidic. That's why the aquatic life becomes difficult. Plants require a specific pH range for their healthy growth. Antacids neutralize the excess acid produced in our stomach to get rid of acidity. You are familiar with this term, acidity. Tooth decay starts when pH of the mouth is lower than 5.5. Tooth enamel, made up of calcium phosphate, is the hardest substance in the body. It does not dissolve in water, but it is corroded when the pH in the mouth is below 5.5. Clear? Now, how this pH becomes low in the body? Actually, when any food items remain in our mouth, then due to the bacterial reaction, this regenerate the acid, and if pH goes less than 5.5, it result in the tooth decay. That's why we use the toothpaste which are generally basic for cleaning the teeth, because it can neutralize the excess acid produced in the mouth by the bacteria and prevent tooth decay. Animals and plants have self-defense through chemical warfare. See some example like this bee sting, or we can say honey bee sting, and stinging hair of nettle leaves. Actually, nettle is one plant, nettle plant. It leaves when touched inject one acid that is called methanoic acid. Commonly, that is known formic acid, and this causing burning pain. And a traditional remedy is rubbing the area with the leaf of the dog plant. Actually, this dog plant release the basic solution. That's why effect of stinging hair of nettle leaves can be neutralized by the dog plant. So these are the importance of pH in our daily life. Now just see naturally occurring acids. Vinegar we use in kitchen. It is contains acetic acid. Orange, citric acid. And again see lemon. This is also the citric acid. Its fruits are also known as citrus fruits. Tamarind contain tartaric acid. Tomato, oxalic acid. Sour milk or curd, lactic acid. Ant sting, this is called methanoic acid. And nettle sting, it contains also the methanoic acid. Now see the some questions. You have two solutions A and B. The pH of a solution A is 6 and pH of solution B is 8. Which solution has more hydrogen ion concentration? We already discussed. Lower the pH, higher the hydrogen ion concentration. Is it clear? Now think you can find out its answer. And which is acidic and which one is basic? If pH is less than 7, acidic, more than 7, basic. Some more question. What effect does the concentration of H plus ions have on the nature of solution? As in this case, you have to compare the concentration of H plus ion with OH minus ion. If H plus ion is more compared to the OH minus ion, that is acidic. If both are equal, neutral. If concentration of H plus is less and OH minus is more, that is basic. Right answer in your own word. Do basic solutions also have H plus ion? If yes, then why are they basic? We already discussed that any solution, it may be acidic, it may be basic, or it may be neutral, always have H plus as well as OH minus ion. Only their relative strength decide solution will be acidic, basic, or neutral. I think you can write its answer. Under what soil condition do you think a farmer would treat the soil of his field with quick lime, That is calcium oxide or slaked lime, calcium hydroxide or chalk, calcium carbonate. Now its answer is, actually if you find out the nature of this quick lime, that is metallic oxide, and generally metallic oxides are basic in nature. Slaked lime, calcium hydroxide, this is basic. Chalk, calcium carbonate, actually this is a salt, and this salt is also basic in nature. If we treat the soil with the base, it means what is the nature of soil? Soil became acidic. Soil became acidic. In the same case, if farmer treat the soil with gypsum, that is gypsum, gypsum, and this gypsum is acidic in nature. It means soil becomes basic. Okay, that is acidic soils are treated with the quick lime or slaked lime or chalk, and basic soil is treated with the gypsum. That's all. Thank you.